All right, we're going to just start off with a little review here. So, what is this fraction of the whole egg carton? Not how many eggs are in there, but what if we divided this into two parts? What fraction does this represent? Okay, you should have said 1/2. This would have been two parts. That goes in the denominator. And we had one part. One part. Now we can say 1/2 of 12 eggs, though, equals 6 eggs. This is a review from before. Look at that. Here's our 6 eggs in that 1/2. All right, so here's the next one. What is this fraction? Again, we got 4 parts and 3. All right, you should have saw the 4 parts goes in the denominator. Remember, I always think of that as the denominator. So we had 4 parts here. 1, 2, 3, 4, and 3 of them are filled in, so that goes in the numerator, and the 4 parts goes in the denominator. Remember, the line's called the vinculum. Okay, now we can say 3/4 of 12 eggs. I have 3/4 of that dozen. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 eggs. Yay. All right, so what is this fraction? This time I'm not going to do it right away but I will just give you a little bit to figure it out. Okay, so you could have paused that if you need more time, but look at this. We had 3 sections. 1, 2, 3. That goes in the denominator. Only one section, though, was filled in. So 1/3 of 12 eggs equals 4 eggs. Okay, think about this one too. Look at your parts, not the eggs right away. Okay, so if you like, I figured that out. Now remember, you can pause it. Is you had 1 section, 2 sections, 3 sections, 4 sections, 5 sections, 6 sections, right? So that's 6. 1, 2, 3, 4, 5, 6. 2 of them were filled in. 2/6 of the 12 eggs equals 1, 2, 3, 4 eggs. That's the same as this. It's just divided up more. Okay, so let's look at this again. What is the fraction? Okay, so you should have said like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sections. That goes in the denominator. 1, 2, 3, 4, 5, 6, 7, 8 goes in the numerator. Okay, so 8/12 of 12 equals 8. Okay, so now we're going to be looking at some combining of eggs, just like we did yesterday with denominators that are not alike. Yesterday we talked about denominators that were alike and how to add and subtract them. So we would work normally with partners to solve this one. We're just going to do a little modeling really quick. Okay, so what we need to do is think about this. How do I get 1/3 of this plus 1/4 of this combined? Okay, so 1/3. So let's see, 1/3. So here is one group. We're going to first divide this up into 3 equal sections. Check. And we're going to just shade in this section. This one's going to go into 4 different sections. So it'd be 3s. 1, 2, 3, 4, and we got one of them. Now we could try to put this in here, but look at our denominators are not the same. And I can't get thirds and fourths together, but I can get it into 12s like we normally say. That's the easy one. So now we're going to be thinking about this. Look at this. If we just divided this one up into 12s, just convert that into 12s times 3 times 3. That's 3 12s. This one here again, let's get it into 12s. And this is 1, 2, 3, 4 12s. And again, the reason why that works, look at this, times 4 times 4. Now we can say, oh, common denominators. We love those. Common means the same. How many 12s? Oh, look at this first. I'm going to divide it up into my 12 equal sections. What? Let's just do it like that. And then we're going to put the 3 12s in. 1, 2, 3. And let's just get a different color. And then we got our 4 12s here. 1, 2, 3, 4. So as you can see here, we're in 12, so that remains the same. The 4 plus the 3 is 7 12ths. And here's a visual of that. That makes our eggs happy when we have common denominators. Okay, this was some ways to do it where we just like we did it. Okay. Now what we could also do is let's look at this. Let's look at 3 12s. So here's your 12s right here. And I'm going to use one color for that. Let's just do green for here. 3 12s. This is already divided up. 2, 3. Now, this one here, this is your 3 12ths. Now in 6, 3 6 would be 1, 2, like this. 1, 2, 3 6. But we have no common denominator here. I could throw those into here, but really it's just like, let's make this into 12ths. 1, 2, 3, 4, 5, 6. 6. And look at that. Times 2. Times 2. Now we got rid of this and we got ourselves a common denominator. So our common denominator is 12. So now we just say equals. We just cha-cha slide that over. And then 3 plus 6 is 9. And look at, we can even look at this. So if we take, let's just do this here. 1, 2, these 6 here. Let's just move them up into this one. 1, 2, 3, 4, 5, 6. We'll divide that up into 12ths. And then we have these three right here. 2, 3. We have the 9 12ths. 1, 2, 3, 4, 5, 6, 7, 8, 9 12ths. This is how you can get an equivalent fraction, so you can get a common denominator. Okay, so we're going to go into working with Workplace 3A, dozens of eggs. This game will help you practice combining fractions. All right, so you're going to need your student book with the Running Man. It's on page 104 and 105. Your fraction cards and all this stuff should be, what we're going to use is that Schoology link that's in there called Dozens of Eggs. Okay, and I'm going to go over the directions first. Players shuffle the cards and lay them flat down. Again, they're already shuffled if you do it online. The players with the largest fraction goes first. The cards just go to the bottom and stack. Okay, again, this is if you'd play it with cards. Player 1 draws a card from the top of the deck and reads the fraction out loud, and then uses a string to model this. So if you got 2/3, and again, you 2/3 here, here's 1/3, here's your 3 parts, and you're just shading it in. Okay, you got to model that. Player 1, let's just go back to the, okay, and then player 2 checks the work. And again, if you don't have anybody at home, maybe somebody, like you have a brother or sister, could play with your mom or dad who's taking care of you, or you can just try it by yourself if there's nobody there. Player 1 draws circles to represent the number of eggs in one of the diagrams. And so here again, if we were doing this, that equals the 3, but we're going to change that into 12ths. So here again, think about this. If these are already 12s and you got these in there, it's a great way to just say, hey, how do we make this into 12ths? Boom, boom, boom. And then it's 1, 2, 3, 4, 5, 6, 7, 8 12ths, which equals 8 12ths. And you draw it down there. Player 1 then, again, we start over, and player 2 takes a turn doing it. The players continue taking turns until one person has filled up all 4 of on their recording sheets. Now, what you're going to do is try to fill this in. So as you went here and you got this in, now you're going to be looking to fill these guys in too with 12ths. So once you filled in all of them, you kind of win. As you can see here, that was your 8 12ths. And say you get another one for 2 12ths. Use different colors, and you got another 2 12ths, which equals 1 whole. Now, on each turn, players must put all the eggs in one carton. However, players may begin to fill another carton if it's completely filled up. So if you got, say you got 4 12ths after this, and you put 2 here, then you can put it in another one down below. Okay, when the carton is filled, the player writes the whole equation then by inserting the signs that show plus 8 12ths plus 2 12ths plus 2 12ths. The winner is the first person to fill all of his 4 or her 4 up. Okay, so let's try doing this one online, and we'll show you what it looks like. Updates have been made to this. Hang on, let's see. Let's try that again. Digital workplaces and dozen eggs. Oops. Okay, so on this one, we'll tell you the directions again. You can read it right off here on this one. And again, more directions. And here is your, so we pick a card. 5, 6. So if I'm player 1, I got to go over here. Okay. So then what 5, 6. Now 5, 6, if you want to convert that over into, if I have, oh, what's that? Hang on. This one maybe? Oh, that's a line. 5, 6. Now, if I was going to do it and I can drag those in, that would be 10 12ths, right? 5, 6. So if you think I'm just 5, 6, let's see. So 6 would be 2. So here would be 1, 2, 3, 4. Oh, I'm sorry. I'm going to do this different. Where's the undo? Let's start over. Erase. I'm going to erase that out because you're supposed to use these little side cartons, I'm pretty sure, to do it, to model it. Okay, so you 5, 6. Oh, 1, 2, 3, 4, 5, 6 pieces. And then you have this, oops, this, 2, 3, 4, 5 sections are filled in. And now if we did this to make it into 12, so it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12s. Now here's where you're going to, then you can drag these right in, do your 10 sections. There we go. Okay, and then your equation would, you'd first start off by doing the 10 12ths. So again, if you're writing on here, you know, you, oops, I gotta get that on. You just do 10 12ths. Okay, then the second person would go and get rid of, if you want, you can just pull these cards to the side. Now the second person would pick a card, 5 12ths. Okay, so let's just get that one over here. It's good. We can put a discard maybe underneath here. 5 12ths. It's already done in 12s for you. Don't have to do any more. So let's just do this one. So he gets 5. 1, 2, 3, and 4, and 5. And then they mark in the 5. Oop, the 5 12ths plus and plus over here. Okay, because that's 12ths already, so that was already divided up. Okay, now, again, I might get on here and erase. Oops, wrong one. I'm not the best at this one. Erase these. And I'm just going to do a couple more just to show you what it is. So again, we pick another card for player 1. Pick 1/2. So if we did 1/2 over here, that's like here. That's this, one section here and one section here, but let's divide that up into 12ths. So 1/2 would be 6 12ths. Okay, so I got 6. Ooh, look at this though. I'm only going to be able to put 2 12ths here. And I'm going to have to put 4 12ths over here. Now here's where you want to use the different colored chips. So X1, 2, and then I got my 4 12ths over here. Keep going. Okay, so you just keep going back and forth like that until somebody fills up their hole. You can go above it. That's last year, I know they said, but I can't get exactly that. Yeah, once you fill it up, even if you have some leftovers, you win. So this is a great way of converting regular fractions to twelfths, all of them to twelfths. Again, some of them are going to be in six. Then you just double that, like 2 12s. Some are going to be in thirds. Some will be in twelfths already. All right. Hope you have fun doing this.